Okay, moving along and looking into solutions of linear systems. And here we have a system of equations represented by this 4x5 matrix. And we'll be looking at attaining any solution where the system is going to be consistent. And this is going to be a consistent system, but one of a little bit of a different variety. And before we get into this, I just wanted to mention, okay, just what the pivot positions and columns will be. Okay, so we have with our pivot positions, okay, so you have starting from the upper left-hand corner, okay, so you have 1, this is above 3 zeros, and then we have next have the next non-zero element, you have this one, and then we have moving down, okay, we have the next leading element, okay, to be at 1, and we have with the bottom row, we have to be all zeros. Okay, so we have what we have in red. Okay, those are going to be where the ones are located. So these will be the pivot positions. And where the positions are located, okay, those columns where each of these will be situated, okay, those are going to be the pivot columns. Okay, now moving along, okay, to looking at solving for the system. Okay, so we have just for the makeup here. So you have 1 0 1 3 5 0 1 3 0 4 0 0 1 2 3, and we have all zeros throughout. And now for what we have in this matrix, now if you notice, you have the one above zeros, this one above zeros. Next leading element is above 0, and that was the last of the leading elements, and you have only zeros underneath. So this form of the matrix is echelon form. And if I take each row and put in terms of what we have in the equation setup, so you have 1 x of 1, and the 0 means we don't have an x of 2 element. Then we have with 1, we have x of 3, and we have plus 3 x of 4 is equal to 5. And then we have with the next row, we have the leading term is going to be x of 2 plus 3 times x of 3. And that is set equal to 4. Notice we do not have x of 1 or x of 4 present. And we have with the third row, okay, the leading element 1, okay, is going to be indicative of all what we have at x of 3. Then we have plus 2 times x of 4. And we have this equal to 3. And we're going to express these equations in as few variables as possible. And we're going to have this expressed in terms of free elements or free variables. And if you notice, okay, we have the equations, okay, so you have x of 1, x of 2, x of 3, but there's no nothing in the fourth row to indicate that we have x of 4 as a leading variable or basic variable. Okay, so we have x of 4 to be what is regarded as free. Now, just looking at what we have, okay, so x of 4 is a free variable, okay, and if we move up the ranks here, so I'm going to express all these equations in terms of x of 4, the free variable. Now for x of 3 is equal to 3 minus 2 times x of 4, okay, and x of 4, okay, is free, and it can have an infinite number of values. Same thing for x of 3. And if I put x of 2 in terms of the free variable x of 4, now right now from x of 2 plus 3 times x of 3 equal to 4, I have x of 2 equal to 4 minus 3 times x of 3. And we have x of 3 in terms of the free variable where we have equal to 3 minus 2 times x of 4. So plugging in, we're going to have 4 minus 3 times the quantity of 3 minus 2x of 4. And if I combine the terms, we have 4 minus 9, and what's going to be plus 6 times x of 4. So I have negative 5 plus 6 times x of 4. And as for x of 1, I have 5 minus x of 3, minus 3 times x of 4. Again, x of 4 is going to be regarded as the free variable. Now for x of 3, again, that is negative 5 plus 6 times x of 4. So moving along, okay, so we have 5 minus the quantity of 3 minus 2 x of 4, and I have minus 3 x of 4, and combining, I'm going to have 2 minus x of 4. So we're going to have for the solution set, okay, we're going to have that x of 1 is equal to 2 minus x of 4. X of 2 is equal to negative 5 plus 6x of 4. X of 3 is equal to 3 minus 2x of 4. And x of 4, again, is free. So any variable expressions, okay, that we have to the right, okay, upon simplifying, okay, those would be what are referred to again as free variables. And now just taking what we have here. Okay, so again, we have in the set, you have what are basic variables with x of 1, x of 2, and x of 3. And again, the free variable is going to be x of 4. And now, in terms of what we have for a solution set, we have the key property that whenever a system is consistent, the solution set can be described explicitly by solving the reduced system of equations for the basic variables in terms of the free variables. Okay, now I arrived at the solution set on just setting up equations from the echelon form. Okay, so this matrix was an echelon form, and now if I were to make this into a reduced echelon form, now we got for each column, the 1 is the only non-zero element. Second column, this 1 is the only non-zero element. Now, if I make the leading element to 1 as the only non-zero value here, I'm going to have to make some adjustments, okay, to make 3 a 0 as well as the 1 at the top. So in terms of manipulating, okay, so I can say that I have, so I'm going from interacting with the 1 in the pivot position. I say I have R1 minus R of 3. And to make this 3 into a 0, I'm going to be looking at 3 minus 3 times 1. So I can say that I have R of 2 minus 3 times R of 3. So I got 1 minus 3 times 0 is 1. And then we have 0 minus 0 is 0. And you got 1 minus 1 is 0. And then we have 3 minus 2 is going to be at 1. And then we have 5 minus 3 is going to be at 2. Now for R of 2 minus 3, R of 3. So you got 0 minus 0 is 0. 1 minus 3 times 0 is still 1. And we got 3 minus 3 times 1. This will go to 0. And we got 0 minus 3 times 2. So this will be at negative 6. And then we have 4 minus 3 times 3, so this will lead up to negative 5. And so for what we have in this particular development, okay, so we have all the leading elements will be the only ones in the value 1 for each column. So in this particular case, all right, so we're going to have what's going to be the reduced echelon form. And if I take what I have here going row by row, okay, so we have that x of 1, notice there's no x of 2, x of 3, but there is an x of 4 term. I have x of 1 plus x of 4 is equal to 2. For the next row, I have x of 2 minus 6x of 4 is equal to negative 5. For the third row, again, we have x of 3 plus 2 times x of 4 is equal to 3. And again, since I don't have any leading element to represent x of 4, okay, again, we have x of 4 is free. And so again, we're going to arrive at the same solution set. So I have x of 1 at 2 minus x of 4, x of 2 at negative 5 plus 6x of 4, x of 3 at 3 minus 2x of 4, and x of 4 is free. So I still had the same basic variables with x of 1, x of 2, x of 3, and the free variable at x of 4.